Welcome back, Math 9. As some of you know, we are going back to online learning a little bit. And it is tough time, but it's not your first round of doing online learning. So please have it in your mind. I'm going to and try to make lesson video every day and update to both my school, email, YouTube channel, and Google Classroom so that you can always refer it back whenever you need it. For example, when you're doing homework at home, those kind of thing. All right, so today's lesson, ladies and gentlemen, goes to page 11 of your polynomial booklet. So first thing first, we are going to focus on subtraction now. Last time, we learned about two different methods. The first method is using algebra tile, and we use that skill to do any addition of polynomial. In addition, we use algebraic method, which is basically mental math method. So today we are going to go through about two example that involve tiles, and then about 2-3 examples that involve with algebraic polynomial and how we can use mental math or algebra skill. When it comes to first method, let's go through with tiles. Basically, it's a similar thing. We are gonna organize similar type, and then when I mention about similar types, it's more talking about degrees. So if it has square or single unknown variable, or is it constant, those kind of thing. And then we're gonna eliminate if it's needed to, which is called simplification step, and we're gonna put final algebraic expression. This elimination step, we refer it as, how can I say, we refer it as zero pair step. Zero pairing step, just for the heads up. So let's go through a quick review first. When we are adding something, we are just combining expression 1 and expression 2. We're combining these guys together. You don't need to think about charges too, except when it comes to field, you can always consider that as a negative, empty one as positive. So what I mean by that is positive x squared, anything x squared is a big square, negative 3x, that's a single term, and it's negative. So it should be color strip, positive 2, too small tile, integer tile if you will. When it comes to followed by negative 3 x squared, fancy way of saying big filled square, 2 filled strip, 1 empty integer tile. Find out any zero pair now because we are combining it. These two cancel out to 0, and that's about it. So when you write down the final expression, we can just say negative 2x squared, descending order, highest degree to lower degree, minus 5x plus 3. That was how we did in addition. When it comes to subtraction, here's what we do. Expression 1, we use the same step as the first one. Write down negative for color, positive for empty, negative for colored or filled, those kind of thing. Now here's the thing. Whenever you have negative, that means whatever followed by expression we are basically using opposite step. What I mean by that is filled will be positive, empty will be negative. This is a fancy way of saying changing the sign basically. I'm going to explain to you why more when it comes to algebraic method. So at this point, just know the fact that this is a normal rule. When it comes to these one, you have to understand that it's a rule that is applied for negative sign. So here's what we're going to do. Negative x squared, fancy way of saying color square. Positive 2x, fancy way of saying empty 2 strip, negative 3 colored tiny square. Now, originally, this is 1 color big square, but we are doing opposite of that, so empty. 3 color strips should be 3 non-colored, and negative 1, which is technically colored, should be empty. This is my expression number 2. The reason that happened is because when it comes to expression over here, it's same as negative 1, and then you have negative x squared minus 3x minus 1, something like that. It is negative 1 that should be distributed for each of them, which I'm going to explain again when it comes to algebraic method. And because of that situation, we are changing every single sign, or people remember as an opposite rule. Do we have any zero pair? Yes, we do. So as a final, I have 1, 2, 3, 4, 5, 5x minus 1, 2. There you go. That's how you do polynomial subtraction when we have the front as a positive and second one as a negative or something like that. Oops. To be fair, as you may notice, it does take quite a long time if you think about it. So what we can do for a method that doesn't use any of the tiles, I call it without tile. Let's go through this algebra method. Algebraic method. Basically, one thing that we need to do is we gotta remove the bracket, but sometimes we gotta change the sign. For example, if I have negative and negative, that means it's positive. If I have negative and positive, that means, whoops, you have negative as a net sign. These two are what we need to expect when we distribute signs. Then we are going to rearrange any of the group with the like terms. Then we are going to do simplification like what I have been mentioning. So let's go through this. I want you to understand that x squared plus 2, it's normal. Write that down. But after that, if you can see this negative, I need to do what I like to call distribution. Distribute. The reason being is subtraction and negative, that's double negative, which means it's going to turning into positive 5x squared. Negative and negative give you positive 1. So you have that as an expression. I want you to rearrange. I have like terms. X squared plus 5x squared plus 2 plus 1. And then we are going to calculate the same term together, which is 6x squared plus 3. Simple as that. That's how we do, folks. On the other hand, if I look at these expressions, as you may know, I have plus situation after the negative. Who cares? Same type of distribution. Write down expression first, x squared plus 5x plus 4. The first term doesn't change. Negative and positive make everything negative. Negative x squared. Negative and positive make it negative again. 4x. Negative and positive, same thing. Negative 1. Rearrange the like term. X squared minus x squared plus 5x minus 4x plus 4 minus 1. In this way, I can calculate like terms together. Fortunately, positive and negative 1, they cancel out to 0. And we don't need to write down the 0. 5x minus 4x give you just positive x plus 4 minus 1. That become positive 3. So the whole answer turning out to be x plus 3. That's how you do. Obviously, a lot of people will use this distribution method for algebraic method. However, understand that you still need to understand how the algebra tile mechanism works. Okay? Now, let's randomly pick some example. Let's see, what about we have, why not the last one? Sometime you have more than one of the terms with a different sign. Same thing. Start with the first left expression that does not affected by the subtraction sign, followed by minus positive, minus 5x squared, minus minus, plus 1. Rearrange, x squared minus 5x squared plus 2 plus 1. Deal with the like terms together. Negative 4x squared plus 3. That's how you do everything, ladies and gentlemen. That is today's lesson. Your job is, first of all, complete all of the question on page 13 of your booklet, followed by I'm going to show you what examples are given in a homework question from the textbook. That is today's lesson.